Okay, 8M7, lesson 19, cones and spheres. We are going to talk today about the volume of cones, volume of spheres, but also the volume of pyramids, which isn't listed in the title, but this is the title the way Eureka Math is currently designated. We're going to talk about how to find the volume of these various objects and some of the nuances and some applicable tricks or some that will be useful for you when you're doing tonight's problem set. Or otherwise known as your homework. Let's get on to our application screen and see what this lesson is all about. So again, today's lesson, this is the summary of today's lesson right here. We have the volume of a cone. A cone looks something like this. I actually have a little live demonstration, which I'm going to try and work for you to show you a little bit more about what a cone looks like. But the way that you can find the volume is either it's 1/3. The formula is 1/3 of the base times the height, where the base is like this the area of this circle here. Like if you took the area of this circle and multiplied it by 1/3 and then times the height, the type from the point all the way to the middle of the base, then you can find the volume of the cone. If you don't know, if you just know the radius, and you don't know the area of the base, you could do 1/3 of pi r squared h, because pi r squared is just another name for the base, right? Pi r squared is the area of this circle. So you could either do 1/3 of base times height if you know the base area, or 1/3 of pi r squared h if you just know the radius of the base, okay? Similarly, the volume of a pyramid is the same as the volume of a cone. It turns out that it's also 1/3 of the base times the height. So in this pyramid, if you think about it, this is our base. So if you take the area of this base and you multiplied it by the height, from the top all the way down to the base, the vertex, they call this the vertex of the pyramid, that would also be the volume of a pyramid. And we have a problem where we work this problem as well. So the way you say it in English is the volume equals 1/3 of the area of the base times the height. And that's true for cones and pyramids. Okay, let's go to point 4 real quick. The volume of a sphere is 4/3 pi times r cubed. So if you have this sphere, think of this could be like a basketball. And you know the radius, the distance from the center to the edge, any edge, because that's radius is the same for a sphere. It's just a perfectly round, three-dimensional circle, if you will. And it's 4/3, it's funny, 4/3 times pi times r cubed, the radius cubed. Okay, and we'll get to that. We'll get to a problem like that at the end. We've learned the volume of a sphere before, but we'll review it here in this lesson. So the last point is this concept of slant height. This is not a concept I think that you've learned to date. It is not the same as the height, but can often be used to calculate the height. So let's look at this ice cream cone, or this cone here. The height is from the top straight down to the base, where you form a right angle with the base here. That's our height. Now our slant height is different. It's from the vertex down the edge of the cone to the bottom. And so this will be longer. The slant height is longer than the height, right? Because if we can actually make a right triangle, and we can use, we'll be able to use our Pythagorean theorem, because if we use our radius and our height, we have a right triangle where the slant height is actually the hypotenuse. So we'll see more examples we'll see another example of this later. And I'm going to try and show you this after this next slide. So this is kind of the overview of what we're doing today. So let's move along to our next slide. And I want to really show you the difference here of this concept of slant height and height. And so the question before us is, what is the volume of each of these cones. So here's a cone where we have a height where if you go from the top all the way down to the bottom, which is also, if you think about it, if you laid this cone on a table like this, it would be the height from here to here. This is the height. And I'll try and show this to you here in a second. Whereas the slant height, we have over here on this cone. This is a different cone, and we're not measuring the height from top to bottom, but we're measuring the length, the height, or the length down the edge. And that's 8. And so in this case, we're going to want to find the volume of the cone. Now let's cut over here for a second, and let me see if I can really bring this home for you. I'm going to go over to another screen for a second, and we're going to see what we can do here. Let's cut over to our, here we go. Let's see how this works out for us. Okay, so I've made this cone. This is me. Here's my hands. Hi, hello. And we're going to try and so I just kind of made it out of paper, and I made a bottom to it. And so notice the cone has a circle for a bottom, and then it has this cone. And so this is like an ice cream cone. I could hold it up and I could say, hey, Mr. Jones, can I have some ice cream? And we could scoop some ice cream here on top, and this would look like an ice cream cone. But we're trying to figure out how much water or how much ice cream or how much air fills this cone. That's kind of the question. What goes inside it if we wanted to fill it up with something? But I want to first I want to make it clear to you that the slant height and the height are not the same thing. So the slant height that's the distance from the top to the bottom edge, right? So it would be, in this case, let's measure that. That's, if we look at that, and come on close, that's about 18 centimeters. About 18 centimeters. But let's look at the height. Now the height is the distance from the middle to the bottom, to the very bottom middle here. But we can't measure from here to here because we can't run a ruler there. But we can maybe approximate it by going, we could just say how tall is it, right? If we just look at how high this thing is. Right? So we're going to measure the height from top to bottom. And we can see that if we zoom in here, that the height is about 16 and a half. Got a little bit of an optical illusion here, but it's not 18, it's 16 and a half. So it's shorter from here to the bottom middle than it is along the edge. That's longer, and from here straight to here is shorter. And I think maybe you can see it. But that's the idea of a cone, the slant height and the regular height. Now let's go back and let's finish this lesson. Okay, so here we go. And now let's go back and share this other screen, and we'll come back here. So again, we had our slant height and our height. So in this case, in this cone where we've measured the height of the cone, and this is a right angle, by the way, we can just say, well, the volume is equal to 1/3 times base times the height. So that's 1/3 of our base. Now our base is, we don't know what our base is, but we do know that the base is equal to the area of this circle. That's our base, the area of the base. So that's pi r squared. So our volume is also, remember, 1/3 pi r squared h. So we're going to take 1/3 pi 3 squared times 6. So that's equal to, we'll put the pi in front, 1/3 times 3 times 3 times 6, because that's 3 squared. 1/3 times 3 is 1, so those cancel. And so we get 18 pi. And what are our units? our units are inches, and volume is cubed. So 18 pi inches cubed. All right. So that's pretty straightforward. That's just pretty much applying our formula. Now over here, it's a little bit trickier because we still need a third of the base times the height, and our base is still, or 1/3 of pi r squared h. And we know what our r is, but we don't know what our h is here, because our h is our distance from the top to the bottom, where this h here is unknown. But what we do have is we have this neat right triangle, which is kind of hidden. But for those of you who see it, I'll draw it here in blue, and maybe everyone can see it. We have a right triangle. And so we have a leg, and a hypotenuse. So let's now use the Pythagorean theorem to find our height. And we get a squared plus b squared equals c squared. And we know our c, which is our length. So 8 squared equals 3 squared, 3 squared plus a squared, which in this case is h. So I can say h squared. So h squared plus 9 equals 81. So h squared equals 72, because I'm subtracting 9 from both sides. So our h is the square root of 72. And if we want to simplify that, that's the square root of 36 times the square root of 2. I'm totally messed this up. This is not, h squared is not 81. I thank you for pointing that out. It's 64. So h squared equals minus 9 is 55. So h is equal to the square root of 55. I like that better. Thank you for pointing that out. So now we can use our formula. So the volume is equal to 1/3 of pi times 3 squared times the square root of 55. So that's pi times 1/3 times 3 times 3 times the square root of 55. Cancel, cancel. So that's pi 3 root 55. And we like to put our pi at the end. So it's 3 root 55 pi cubic inches. Happy cat, happy cat. So what's the key? The key is when you have the slant height, you often need to be finding the real height, which isn't that hard because we know the Pythagorean theorem. Cool, cool. All right, let's move forward. Then we're going to just apply this and find the volume of our pyramid. Now, a volume of a pyramid is 1/3 of the base times the height. And the key is often finding this base. Let's see if we can find the volume of, or the area of the base. Base equals the area of the base. We just say base for short, but it really means, you think about what is the base? The base is an area. So if this base, if I'm telling you the base is a square and one side is 4, how big is this area? What is this, the area? Forget about all this up here. Let's just focus on that down there. Well, the area of a square is just, the side squared, or the length times the width. That's 4 times 4, which is 16. So now we can just come in and say, well, the volume of our pyramid is 1/3 of 16 times 10 equals 1/3 times 160, which is equal to 160 over 3, which if you divide that out, you get 53 1/3 centimeters. And remember, our units, whenever we deal with volume, it's always cubic. So that's volume of a pyramid. Sometimes a pyramid, let's just do another one. I want to, just in case, pyramids don't always have to have square bases. Sometimes you might see one with a triangular base. Like this. And in this case, let's just pretend, let's just put some dimensions on it. And I want to say the height equals, 9 inches. And let's just say that the base, someone's already calculated the base for me, and they say it's 12 square inches. So someone's just measured this base and told me 12 square inches. So now I can just say the volume is equal to 1/3 of base times height, which is equal to 1/3 of 12 times 9, which is equal to, well, 1/3 of 12 is 4. 4 times 9 is 36. So 36 inches cubed. So remember, key point, pyramids can have 3 or more edges on the base, right? This pyramid had 1, 2, 3, 4 edges. So the base was this square. It could be a rectangle or any quadrilateral. But here the base is 12 inches. But this here, the base is a triangle. But the formula always applies. The formula is always 1/3 times the area of the base times the height. Okay, all right, well, let's do a happy cat on this guy. And then let's move along. Now, in this case, we have a different problem. We have the slant. We have a pyramid, but we didn't measure. We can't measure from the top straight down. We don't know what this height is, but we do know what the slant height is. The slant height from here to here, we've measured at 4 inches. So the question is what is the volume of this pyramid? Well, we can use that same trick that we used back on the cone, and we can build a right triangle here. So first of all, let's figure that guy out. So we're going to build this right triangle, boom, boom. And in this case, we know there's actually 2 ways we could have done this one, but let's just do it this way. So the slant height is 4. Oh, wait, we don't know what this guy is here. Aha, this is really tricky. We don't know what the radius is. So what we have to do in this case is we have to find what is this distance here. And this distance is going to help us figure out the answer to our question. Okay, so if this whole distance here is 4, sorry, this whole distance is 6. So it's 6 from here to here. How far is it from here to here? Well, that distance has got to be 3. So if it's 3 along one of the sides, and it's 3 along from here to here, then from the center to the middle is going to also be 3. Okay, so here we have 3. And along this blue line, we have 4. So now we can draw our final piece of this triangle, which is another right triangle, and we have this triangle here. And so we have a right triangle, and now we can find the height. Right? So we know that leg, we don't know this leg, which is the height, and we know the hypotenuse, which is our slant height. So we can say our height squared plus 3 squared equals 4 squared. So 9 equals 16. H squared plus 9 equals 16. So h squared equals 7. So h equals the square root of 7 inches. So now we can almost go about figuring this out. The volume. Volume is 1/3 of base times height. Well, our height now we know is 7. So we have this, check. We know what 1/3 is. Our base we still don't quite have, but we do because we know that it's a square. Base is square, and the sides are 6 inches long. So our base is equal to 6 squared, which is 36. So inches squared. So our volume is equal to 1/3 of our base, which is 36 times root 7. So that's equal to 1/3 of 36 is 12 root 7 inches cubed. Lot going on here. Calculating that center, or calculating this piece of the right triangle, and then using the slant height to help us figure out the full height. That was the key to this puzzle. That was the key to this puzzle. All right, let's happy cat that guy, big happy cat, and let's move along to our almost our final problem. And this is an interesting one. So we have the Earth. And the diameter of we're going to just do an estimation problem. And we're going to use the volume of the sphere of 4/3 pi r cubed, and the diameter of the Earth about 8,000 miles. And we're going to figure out what the volume of the Earth is. So if you think about the diameter of the Earth, the distance across it, from the North Pole to the South Pole is where the penguins hang out. North Pole is where Santa hangs out. That's 8,000 miles. That's our diameter of the Earth. So if our volume is equal to 4/3 pi r cubed, well, we don't know what the radius is. So see if you want to pause and try this yourself, go ahead. So pause and try, and then I'll give you the answer. Okay. So the diameter over 2 is the radius. So 8,000 over 2 equals 4,000. So that 4,000 is our radius. It's half of this distance is 4,000. So let's see. The volume is equal to 4/3 pi times 4,000 cubed. Oh my goodness. 4,000 cubed is a very big number. Well, if I were to say this, we could use scientific notation. And I'm going to use scientific notation to help me with this problem. And so that's equal to 64 times 10 to the 9th. If you want to do this without scientific notation, you can. But I'm going to use it to my advantage. So that's equal to 6.4 times 10 to the 10th. And so I'm going to take that back over here and plug that in. 4/3 of pi, I'm actually going to stick with this version, times 64 times 10 to the 9th is 1 with 9 zeros after it. So I'm just going to do an estimation. So 4/3 of pi is about 4. 4/3 times 3.14 is about 4. And you can verify that on your calculator, or you can say, well, 3.14, I can kind of cancel that with 3 if I'm sticking with an estimation. So this is an estimation. So we're going to say that's 4 times 64 times a billion. 4 times 64 is 128.5. 4 times 64 is 128 times is 256. 256 times a billion is 256 billion cubic miles. And again, this is just an estimate. Because again, I took 4/3 and multiplied it by pi and got about 4. And you know, the diameter of the Earth is about 8,000 miles. So again, this is just close. So if you tried to fill up, that's a lot of water, that's a lot of dirt, that's a lot of something. If you wanted to try and make another Earth out of something, you'd need a lot of something to do it. Okay, let's go to the last problem. And this is a problem that exists. This is on your homework. This is homework help, because you have a problem like this. So you have this sphere. And you found out that if on this sphere you drew a line inside the sphere from one point to another, and then you connected those 2 points to the radius, to the center of the circle, in other words, the sphere, in other words, drawing a radius, that it would make a right angle. You just found this magic point. Not all points will do this, but you found one. You found 2 points where that's true, and then you measured the distance on those 2 points, and it was 4 inches. Now the question is what is the volume of this sphere? And the question that, let me give you some hints. First of all, the volume is equal to 4/3 pi r cubed, and then you're going to need to use the Pythagorean theorem to find r. All right, I'll let you pause and try. Pause and try. Okay, I assume now that you're back and you've given this a good effort. So let's look at this. Well, we have this right triangle here where r and r are your legs. So we have r squared plus r squared equals 4 squared, right? A squared plus b squared equals, you know, c squared. And our c squared is 4. This is our hypotenuse. And these are our legs. This is leg 1. And this is leg 2. And these are both radiuses. Okay? So now we have r squared plus r squared is 2r squared equals 16. So r squared equals 8, dividing both sides by 2. So r is equal to the square root of 8, which is equal to the square root of 4 times the square root of 2, which is equal to 2 root 2. So that's our r. Now we can find our volume. 4/3 pi times 2 root 2 cubed. Okay. Well, 2 root 2 cubed is the same thing as 4/3 pi times 2 cubed times the square root of 2 cubed. So that's equal to 4/3 times pi times 8. Square root of 2 times the square root of 2 cubed is the square root of 2 times the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is 2. So now we get 4/3 pi times 8 times 2 times the square root of 2. And so that's 6, that's pi. I'm going to reorder things a little bit. 4 pi times 4/3. I'm going to combine 8 and 2 into 16 root 2. So my answer is 64 root 2 over 3 pi inches cubed. Let me write it again a little bit more neatly. 64 root 2 pi over 3 inches cubed. And that deserves a happy cat. There's a lot of trickiness going on here, a lot of subtlety, a lot of building blocks. Pythagorean theorem, volume of a sphere, combining like terms, finding square roots, and simplifying, performing exponential operations on radicals, simplifying radicals that are being cubed, and then rewriting using commutative property on multiplication to then simplify. So there's like about 8 building blocks here. And if you stuck with it and you got to the end here, congratulate yourself. Super duper happy cat on that. But just being able to follow the flow, you're going to be able to need to do a problem like this on your problem set. Okay, let's wrap it up then and call it a day for lesson 19. And we'll be back with you on lesson 20 very soon. Over and out.